Fractions are very important when working in the technology and skilled trade fields. Now, whether you want to measure materials for a construction project or whether you want to adjust a recipe if you're a chef working in a restaurant in the hospitality field, we need to know about fractions and we need to learn and be familiar with how to work with these fractions. So we are going to do a brief review on fractions, and we're also going to review how to add, subtract, multiply, and divide fractions. Let's start with part A, simplifying fractions. A fraction can be reduced to its simplest form. This can be done by dividing the numerator and the denominator by the greatest common factor. This means we're looking for the greatest number that can be divided into both the numerator and the denominator evenly. So let's take a look at example A. We have the fraction 12 over 16. Comparing 12 and 16, we see that both can be divided by 4. So let's go ahead and do that. We're going to divide the numerator 12 by 4. And we're now also going to divide the denominator by 4. And when we do that, we get 3 divided by 4. So we can say that the fraction 12 over 16 in its simplest form is the same as the fraction 3 over 4. These two fractions, 12 over 16 and 3 over 4, are equivalent. Let's practice now with example B. We have the fraction 9 over 15. If we compare again the numerator 9 and the denominator 15, we notice that both of these can be divided by 3. So let's take 9 and divide it by 3, and let's also take 15 and divide it by 3. And so what we get is 3 divided by 5. So 9 over 15 is the same as 3 over 5. Now, these two examples, 3 over 4 and 3 over 5, these are known as proper fractions because the numerator is smaller than the denominator. But there are other ways that we can express fractions. And one of those ways is as a mixed fraction. In a mixed fraction, you'll have a whole number with a fraction beside it. And we can take these mixed fractions and we can rewrite them into an improper fraction where the numerator is going to be larger than the denominator. So let's take a look at this mixed fraction 2 3/4. This means we have 2 wholes and 3/4 as well. So in order to change this mixed fraction into an improper fraction, the best way is to take 2 wholes and rewrite it in terms of a fraction. So we see here that the denominator is 4. This means 4 equal parts will make up 1 whole. So if I want to rewrite 2 wholes, I'm going to rewrite it as 4 over 4, that's 1 whole, added with another 4 over 4. That would be 2 wholes. So I'm going to make a little note here, and I'm just going to say that what we have right now is the same as 2 wholes. And what we have to add as well is the 3/4 that's left. And now we're going to continue to add these fractions together. So our 2 wholes, we have the 4 over 4 added to another 4 over 4. That's going to give us a total of 8 over 4, and we still have the 3 over 4 remaining. So 3 over 4 plus the 8 over 4 as our 2 wholes, that's going to give us a total of 11 over 4. And so 11 over 4 would be the improper fraction that represents 2 3/4. So we'll see here that this is our improper fraction, as we see here. So now that we have reviewed our fractions, let's now talk about how to add, subtract, multiply, and divide our fractions. Now, as you saw in our previous example, fractions can be added if there is a common denominator. When the denominator is the same, this allows you to add or subtract the numerators. Sometimes you may need to change the denominator of a fraction so that all the fractions have a common denominator. So let's practice with these examples here. So first we have in example A, we want to take 1 over 5 and we want to add it to 2 over 5. Now again, the general rule with adding and subtracting fractions is that the denominators have to be the same. In this case here, we see very clearly that the denominators of our two fractions are the same. So this makes it very simple for us because all we have to do is simply add the numerators together. So if we take 1 over 5 and we add it to 2 over 5, we will get a total of 3 over 5. Now in part B, we see that it's slightly different. If we compare the denominators, they're different. We have 4 and we have 5. So what we want to do before we can add these two fractions together is we want to get the same common denominator. So we look at 4 and we look at 5, our denominators, and we try to come up with the lowest number that both 4 and 5 can be divided into. And so if we compare, we see that 20 is going to be our common denominator. So I want to take, instead of writing 1 over 4, I know that this needs to have a denominator of 20. Now, if I want a denominator of 20, that means I had to have multiplied the 4 by 5. Now fractions, again, whatever you do to the top or bottom, you have to do the same for the opposite. So if I multiplied the denominator by 5, I have to now also multiply the numerator by 5. So this means that 1 times 5 is going to give me 5. So what this means is that 1 over 4 is going to be the same as 5 over 20. Now I'm going to add that to 3 over 5, but again, I need a common denominator, and it has to be 20. So in my denominator here, I need to multiply the 5 by 4 to give me 20. But if I multiply the denominator by 4, I have to now also multiply the numerator by 4, and that's going to give me 12. So now that I have my two fractions with the same denominator, I have 5 over 20, and I'm now going to add it to 12 over 20. This allows me to simply combine the numerators. So I have a total of 17 over 20. Let's continue to practice with some other examples. Let's look at part C. In part C, we have 3 over 8 subtract 1 over 24. Now again, looking at the two denominators, 8 and 24, we see that they are different. But in order to subtract these two fractions, those denominators have to be the same. And if you compare between 8 and 24, we see that the lowest common denominator here is going to be 24. So I need to change in my first fraction, 3 over 8, I need to multiply the denominator by 3. And that's going to give me 24. So I have 24 as my denominator, but again, what I did to the bottom, I have to do to the top. So I'm now going to multiply the numerator by 3 as well, and that gives me 9. So 3 over 8 is going to be equivalent to 9 over 24. And now I'm going to subtract the fraction 1 over 24. I don't need to do anything here because the denominator is already 24. And what this gives me is 8 over 24. Now take a good close look at this fraction. I want you to ask yourselves, is this in its most simple form? Because if it isn't, we need to continue and go one step further and reduce this fraction, just like as we did at the top of this video. So looking at 8 and 24, we see that we can divide both of these numbers by 8. So if we divide 8 by 8, we get 1. And if we divide 24 by 8, we get 3. So when we subtract 3 over 8 and 1 over 24, we get 1 over 3 as the simplified answer. Perfect. Now let's move on to example D. Now here we have a mixed fraction, and we're going to subtract it by 1/2. So we have 2 1/3 minus 1 over 2. So what we want to do is we want to first take 2 1/3 and we want to write it as an improper fraction. So what we can do is what we did at the top of the lesson is we can take 2 1/3 and rewrite it as, now notice that the denominator here is 3, right? So 3 equal parts is what's going to give us 1 whole. So you could go 3 over 3 plus another 3 over 3. That's what gives us 2 wholes. And then we still have the 1 over 3. So this part here gives us 2 1/3. I'll just keep that in brackets for now, just to indicate that that represents the fraction 2 1/3. And I'm going to subtract 1 over 2. Now in that bracket, again, we have 3 over 3 plus 3 over 3 plus 1 over 3. If we combine all those numerators together, we're going to get 7 over 3, and we're still going to subtract it by 1 over 2. Now again, notice here that the denominators now are different, right? So we need to have the same denominator. And if we compare, we can see that 6 is going to be the smallest number that both 3 and 2 divide evenly into. So for the fraction 7 over 3, if we multiply the denominator by 2, that gives us 6 in our denominator, but we have to multiply the numerator by 2 as well. So we're going to multiply 7 by 2, and that gives us 14. Next, the fraction 1 over 2, I need 6 in my denominator, so I'm going to multiply my denominator 2 by 3 this time. And that's what gives me 6. And my numerator, I have to multiply by 3 as well. So that's going to give me 3 over 6. And so now that I have the same denominator, this allows me to simply subtract my numerators. So 14 over 6 minus 3 over 6 is going to give me 11 over 6. And if I look at this final answer, 11 over 6, I see that it is already in its most simple form, so I don't need to continue to simplify because it's already simplified. Now we're going to continue on, and we are going to multiply fractions. Now, multiplying fractions, we're going to multiply the numerators together, and then we're going to multiply the denominators together. And then, if necessary, we're going to reduce the fraction. So let's start off with example A. I have 1 over 2, and I'm going to multiply by 7 over 16. Now, this is straightforward again, because here we're simply going to multiply again across. So, multiplying across, we get 7 times 1, which is 7, and then 2 times 16, which is 32. So this fraction becomes 7 over 32. So when we take 1/2 and we multiply it by 7 over 16, we're going to get 7 over 32. And if I take a look, this is already simplified. I don't need to do anything more because there's no other number that can be divided into 7 and 32 evenly. Let's practice with example B. We have 3 over 4, and we're going to multiply it by 5 over 8. So again, in multiplying fractions, it's very straightforward. Let's just multiply the numerators together. So again, let's just take 3, and we're going to multiply it by 5. That gives us 15. And then we are going to multiply the denominators together. So we'll take 4 times 8 and we'll multiply that together. That will give us 32. So we have 15 over 32. And if we ask ourselves, is this the simplest fraction? Is it in a simplified form? Between 15 and 32, there's no other number that can be divided evenly into 15 and 32. So 15 over 32 is our reduced fraction. The last thing we're going to cover now is dividing fractions. So in dividing fractions, what we want to do is we want to take the reciprocal of that second fraction and multiply then the two fractions that are there. When we say reciprocal, this means you want to flip or you want to invert that second fraction. So what does that mean? What does that look like? So let's take a look at example A. We have 1 over 16, and we're going to divide it by 2. Now remember, if you see a whole number in a fraction, in its fractional form, this represents the fraction 2 over 1. So when we are dividing, we're going to take, in this case, 1 over 16. And again, the general rule is we're going to now multiply by the reciprocal of the second fraction. So if that second fraction right now is 2 over 1, we're going to take the reciprocal. That means we're going to flip it so it becomes 1 over 2. Just like that. And then now that we have a case of multiplying two fractions together, just as we saw in the previous examples, very straightforward, we will now multiply the numerators together. So 1 times 1 is 1. And then we're going to multiply the denominators together. So 6 times 2 is going to be 32. So the answer here is 1 over 32. Let's take a look at example B. Now we have 3 over 8 and we're dividing it by 1 over 4. So again, when dividing fractions, the general rule is you take the first fraction, 3 over 8, don't touch it, and then we're going to multiply by the reciprocal of the second fraction. So if we look at our second fraction, 1 over 4, the reciprocal, when you flip this fraction, it's simply going to be 4 over 1. And now that we have the multiplication of two fractions, again, should be pretty straightforward from here. We're going to multiply our numerators together. So 3 times 4 gives us 12. And then if we multiply the denominators together, 8 times 1, this will now give us 8 in the denominator. Now take a look at that fraction again. Is this in its most simplified form? The answer is no, because if we look at both 12 and 8, we see that the number 4 can be divided into both 12 and 8. So if we take 12 and we divide it by 4, we get 3. And if we take 8 and we divide it by 4, we get 2. So in this video, we have looked at fractions, we did a brief review, and we also saw how we can add, subtract, multiply, and divide fractions, which again, fractions will be very useful when working in the technology and skilled trade fields. We have looked at the different systems of measure, and we have seen that there are two different systems. There's the metric system and the imperial system. In the metric system, for length, we might use units, which include the millimeter, centimeter, or kilometer. For mass, we might use grams or kilograms. For volume, we might use milliliters or liters, for example. In the imperial system, for length, we might use units which include inches, feet, or even miles. For mass, we might use pounds or ounces. And for volume, we might use gallon or quarts. Now, it's useful to know how to convert within each of these two different systems. So let's take a look at how to do that with our examples. In the first example, A, we want to convert 9 feet into inches. So how do we do that? Let's take 9 feet, and now I want to multiply it by the conversion factor. If we take a look in our chart, we see that there are 12 inches for every foot. So what I'd like to do is I'd like to take 12 feet, and I want to now multiply it by the conversion factor. I know that there are 12 inches in every foot. Now, before we move on, I just want to show you how we know that we've set up our conversion factor properly. So here's a little hint. Take a look at the units you want in the end. In this case, we want inches in the end. So when I set up my conversion factor, I want to make sure that there are inches in the numerator. And this is helpful because when I continue to multiply, I see that the feet are going to divide out. So this means that I'm going to take 9 and multiply it by 12 inches, which is going to give me 108 inches. So this means that in 9 feet, we have 108 inches. Let's now move on to example B. In this case, we want to take 12 quarts and we want to convert it into gallons. So we're going to do the similar thing. We're going to take 12 quarts and we now want to multiply it by the conversion factor. Again, looking in our chart, we see that for every gallon, there are 4 quarts. So let's set up our conversion factor. Because I want gallons in the end, I'm going to make sure to put gallons on top. So I'm going to put 1 gallon, and I know that in every gallon, there are 4 quarts. And so now when I go to multiply, I see that the quarts are going to divide out. So this leaves me with 12 times 1 over 4. And I'll write it as a division because that's the same as 12 divided by 4, which is going to be the same as 3 gallons. So this means that 12 quarts is going to be equivalent to 3 gallons. So what we've done here is we have converted within the same system. But what's also useful to know is how to convert between the different measurement systems. So example, if you want to go between the metric system and the imperial system, or the other way, how do we do that? So there are conversion factors set up here, and this is what we see in the chart. So for example, for length, we know that in 1 inch, that is the same as 25.4 millimeters or 2.54 centimeters. For mass, for example, if I want to go again between the metric and imperial system, I know that 1 pound, for example, is the same as 0.454 kilograms. And for volume, similarly, if we're going between gallons and liters, we see that 1 gallon is equal to 3.785 liters. So we can use these conversion factors to convert between the metric and the imperial systems. So let's practice how to do that. Going from the metric to the imperial system, or maybe the other way around. In our first example, A, we have 5 feet, 11 inches, and we want to convert that into centimeters. Now, it's interesting to note that in 5 feet, 11 inches, there are 2 different units here. We have feet and we have inches. Ideally, we only want to work with just 1 unit. So let's convert 5 feet, 11 inches into inches. And so we're going to do then what we did at the very top. So I'm just going to write this little note. Let's first convert 5 feet, 11 inches to inches. So in 5 feet, from what we did in our previous examples, I want to see how many inches 5 feet is equal to. And using my conversion factor, if we remember, there are 12 inches in every foot. When I go to multiply, I see that the feet will divide out. So that leaves me with 5 times 12 inches, which is 60 inches. So that means that 5 feet, 11 inches, 5 feet I can replace with 60 inches. I'm going to add that to the other 11 inches that are there. And I see now that 5 feet, 11 inches is the same as 71 inches. So now that I have that in 1 unit alone, I can now continue to convert into centimeters. So I'll make this little note. Let's now convert 71 inches to centimeters. So I'll take 71 inches, and I'm now going to use the conversion factor that I see here up in my chart. So notice at the very top, in 1 inch, we have 2.54 centimeters. Because I want centimeters in the end, I'm going to put my 2.54 centimeters in my numerator of my factor. And so there are 2.54 centimeters for every inch. Now I'm going to multiply, and I see again that my inches will divide out, which is perfect. So I have 71 times 2.54, and if we go to calculate that, that will give me 180.34 centimeters. So here we have that 5 feet, 11 inches will convert to 180.34 centimeters. Let's move on to example B. Here we want to convert 4.5 gallons to liters. Now, this example is a lot easier than the other one because our original value, we have 4.1 gallons. So there's already 1 unit. We don't need to do any other conversions ahead of time. So let's take 4.5 gallons. And again, I want to convert it to liters. And if I look at my chart, I see that there are 3.785 liters for every gallon. Now, because I want liters in the end, I'm going to set up my conversion factor so that liters are in the numerator. So I'm going to take 4.5 gallons, I'm going to multiply it by 3.785 liters by 1 gallon. So when I go to multiply, I see that the gallons will divide out. So that means I have 4.5 times 3.785 liters, which will give me a grand total of 17.0325 liters. So 4.5 gallons is equivalent to 17.0325 liters. And that is how we convert between the metric and the imperial systems.
In my career, we use math every single day. We use it for weight calculations for rigging. We have to use it for measurements for pipes to make sure that they will fit. It's a very important part, and it's used on a very daily basis, whether it be from blueprints to layout to fabrication to installation to, once again, hoisting with the cranes. It's all very important. Keep everybody safe, make sure the job's done right. Use systems to measure every day. Use it for layout, fabrication. We measure in both imperial and metric, so we use fractions, and we also have to do a lot of conversions. There's a lot of division and multiplication as well, multiplying and dividing fractions too.
This one, I will say precision and creativity. Why precision? In welding, we said we have four things to do a good weld. To do a good weld, you have to check your angle, your distance, your position, and your spin. And those things, you need precision. We use math in everything. Math, it's a part of welding. I will say fabrication. Fabrication, because you need to calculate angle, convert metric in imperial. You need to calculate your weight. It's part of everything. Math, honestly, you need to have a base for a lot of things. For reading blueprints, you need to check to use math. Maths, pipe fitting, even for the pipe, you need to use maths. So,
for me, one thing I realized was geometry. Patient movement, the stretcher, the angles that we have to calculate to fit through narrow doors, narrow hallways, things like that. I never thought it would be so useful in this career.
The big part of the mathematics in our career has to do with the medical math, so calculations in regards to the medication that we have to administer. Some are pretty simple. We have morphine, 10 milligrams, and 10 milliliters. We need to get 5 milligrams. How many millimeters are we going to get? Fairly simple. You have dopamine here. We have 200 milligrams and 250 cc's. We have to give 5 micrograms per kilo per minute to a adult male that weighs 60 kilos. And to do this, you need to use one of these here, where you have 60 drops per millimeter. So my question to you is, how many drops a minute must you give to this patient? If you give none enough, their heart will fail and the person will die. If you give too much, you're going to create lethal cardiac arrhythmias and the person will die.
So another calculation that you might have to do is for a drug called midazolam. We give that drug for patients in seizures. So I'll give you an example. You're called for an 8-year-old patient in seizures, convulsions. So we need to figure out how much medication we're going to give them. That medication is also weight-based. Now we need to figure out how much the patient weighs. Now, if the parents can't tell us, we use the calculation, and it's the age times 2 plus 10. So in this case, 8 times 2 plus 10.
The little things, like I said, with math, you still have to be able to do basic adding and subtracting when it comes to customers. Some places will use a register, but if you're a business like mine, you don't necessarily have a register, so you have to be able to do the math on your own. It's basic math, but you still have to be able to do it on your own to calculate the cost of everything. At my barbershop, tax is included, so it makes it a little bit easier, but you still have to be able to do it on the fly. If you have boys, then the boys would get that, and it's only if they're cutting their hair really short. If they're not cutting their hair that short, then you're not going to get that. You might get a 2 on the side, or a 1 on the side, or half on the side, but you're not gonna get low on top unless that's what you want. Some ladies, I have done a lot of ladies where they'll shave off the side or shave off the back. I do have a lot of female clients as well. A lot of times you may not realize that that's what you're actually doing, but you have to be able to talk to the clients and figure out what it is that they want. So I go level by level. So especially if somebody doesn't know what they want, in terms of the haircut, they don't know all the levels, just like you're not sure of your level, but you want to cut your hair off. I had a client this week, he has really long hair and he wanted to cut it off. I said, are you sure you want to do that? I asked him multiple times. So we had to get to the level, right? I looked at his hair, I said, okay, he wants it short. I usually start at levels higher.
Math plays a role in my job in several ways. I handle daily sales transactions, dealing with petty cash, calculating costs, processing payments, managing a till. I review, reconcile, and compile financial reports at the end of each day and month, ensuring accuracy and completeness. Fractions and measurement systems come into play when assisting visitors with travel distances and estimated travel times. I use measurements with maps to calculate distances. I calculate expected travel durations. I help visitors plan efficient routes. This includes converting kilometers into miles for international visitors, measuring scale distances, and providing accurate directions